Hey, how you guys doing? I'm Billy Hoffman from SPI Dynamics.
And I'm Brian Sullivan from SPI Dynamics. And we're going to be talking to you today about premature ejaculation.
It's actually, we weren't really going to use that title originally, but we decided, sure, why not? It fit what we wanted to talk about. Premature ejaculation is basically when a company decides to embrace a new, trendy, and interesting technology without thinking about the security repercussions. Maybe they're under a time bind. Maybe their boss is on to get some bug fixes in. I mean, we're all in the security space. We all realize that security is the redheaded stepchild that's thought about after the fact. Some of the symptoms we see here.
We've got embarrassing data leakage, which leads to unsightly privacy discharge, irritation in your compliance areas, and then the unfortunate unsanctioned backdoor access.
So if you've heard us talk about these things before, it's because we had. I was here last year. I gave a presentation called Ajax Insecurities, where we talked a lot about the increased attack surface that an Ajax app has because of its responsiveness to web services. We talked about code transparency issues. You're writing more and more of the application, between a third to a half of it, in JavaScript on the client. And so what can we do with that stuff? And this was very interesting, and this presentation kind of complements that, saying, if we were developers and not security professionals, and we went out there and wanted to make a website, an Ajax site, and used advice out there, how insecure would the app end up being?
And this is exactly what we did. So before we were talking more in abstract concepts or high-level things. This year we wanted to take it down to the concrete, to the details. So we created this website called hackervacations.com. And the way we created it was, we went out and we said, if we were a new Ajax developer, what would we do to learn how to program Ajax? Well, we'd look for blogs, we'd buy some books, maybe we'd go to some conferences. So we did all these things, and we gathered all this information together, and we created this Ajax application, hackervacations.com, with all this advice that we got. And now, was it a great website? Was it very flashy UI and highly performant? Yeah. Was it also a huge gaping security hole? Yeah.
And we have to stress this here, and we'll in fact reveal the sources of where we pulled every example you're going to see us talk about. We did not bake any security vulnerabilities into this. None of these are fake. None of them were Brian sat there and said, you know what, let's not use the parameterized SQL statement. Let's do an ad hoc SQL statement so we're vulnerable to SQL injection. We used straight the advice they told us. Every now and then they gave us a piece of good advice that had the consequence or kind of a side effect of also kind of doing security, but we didn't bake any of this stuff in. So
let's get to it.
Let's just go ahead and show you the app. So this is Hacker Vacations.
Where you name your own price.
or set your own price.
Somewhat literally.
Yes. So, you can go ahead, hold on. There's not supposed to be a proxy on it right now. So, just like a typical Expedia type site, I'm going to go ahead, log in. So you can search for flights. Everything here is kind of, standard thing. Let's go from Atlanta to Vegas on the first, sure. I like window seats. All right, so there's a breakpoint. I'm already getting ahead of myself. So we can tell that this site's using Ajax because we just got a bunch of results back. The page didn't update. We're still on search.aspx. We can do this again. There's a lovely thing we're going to be using throughout this presentation called Firebug. Anybody familiar with it? It's phenomenal.
Yeah. Fantastic. You all should definitely be using it.
Y'all should definitely be using it. So right over here, we actually can see in Firebug under .NET that, in fact, an Ajax request was made. We can look at the post data and see that this appears to be a big blob of JSON saying the start city, destination city, all that stuff. And the response we got back was a big blob of XML, which obviously is how Ajax apps differ from traditional apps. There's a data transport layer here. Basically, our actions are being trapped by JavaScript. JavaScript's making a request behind the scenes, taking the response, processing it, and bubbling it to the user.
Let's keep moving. Let's keep using the application. So we found that we searched for flights, found these, and now we're going to put a bid on it. So what do you think? The 8:30 is probably a little too early.
No. 9:10.
Let's try the 9:10. So we're going to get on this. So the flight is departing on the 1st at 9:10, arriving at 10:35. We've got 8 seats left, and
we're on a budget.
Let's make them an offer. Let's say $20. Yeah. Let's see if that's enough to do it. So right here you can see that we're getting this little status, holding seat, making a $20 bid. Our offer was apparently refused. It wasn't good enough. Releasing the seat and done. And these are all apparently Ajax calls because we didn't see the page refresh.
So let's go ahead, 99. I mean, we did get bought by HP. I think we can afford more than $20 for an airplane seat. So making a $99 bid on the flight, booking it, debiting the account by $99, done. Okay, that all seems interesting. We can go ahead and check out itineraries. We've got a flight booked. We booked it 10 seconds ago. Everything here seems great.
Now let's go back to Firebug.
So let's see, since we know that kind of Ajaxy stuff is going on, let's take a look at Find Flights first and see actually what happens when I click that button. And a lot of things with hacking Ajax apps involves really analyzing and looking at JavaScript. So I'm going to see what happens when I click on the Find. It calls a function called search for flights.
Now Billy hit on something really profound, which is that so much of the application exists on the client side in JavaScript. This is not your traditional web application where 90+% of it happens behind the scenes. You can really see into the application. You can really see exactly what's being done.
So here we see that basically I'm just pulling some information from the input boxes, the information city, the origin city, departure date, all that fun stuff. And then I'm going to go ahead and actually make an Ajax call to flight search. And if we look over here in this common.js file, we scroll down and we can actually see that there's all those Ajax calls here, just kind of, make offer, flight search, all of these things, just kind of wrap actually making a request. So the interesting thing is, let's see what happens when we actually get back from the flight. When we're done, it actually calls right here, search for flight callback, if y'all can see that. So right here, this function is what gets called. We see a parse XML, mainly because we got a big blob of XML back.
So again, we're looking through the result XML, and we get to here, and this is kind of interesting. So we see results to display, and then if results are greater than the max results, then we truncate it. So if we were to have looked at the XML we got back a lot more than the 3 flights that we saw because of this truncating of the max length. But let's say we don't want to do that. We're going to do something really something pretty simple. Instead of taking the programmer's advice and saying, I'm only going to show you the top max results, number of results, we're going to show you all of them.
So we can use Firebug actually to set breakpoints here. And this is going to be an underlying theme, right? Everyone's heard you can't trust the client. It's the #1 rule of web security. Well, if you can't trust the client, how do you trust the client to run any JavaScript you give it? And when half your app is existing on the client, there's a lot of uncertainty about the order operations are supposed to take place, that data doesn't get tampered with between certain types of operations. And so here we can see we can alter the data.
So max results right now is set to 3. But I don't want it to be 3. I want it to be 99, because I don't think we're going to get back more than 99 results. And if we do, I don't really care to see them all. So I'll proceed from here. Okay. And now instead of only 3 results, we have 8 or so. So this was a very, very simple example of a much more profound overall concept, which is that the code that the programmers intended us to do, we chose not to do that. And we can choose not to do that because that code is executing on the client. Anything on the client is outside your control. You have absolutely no control over it, and we can do various levels of evil things, and this was only the first of several nasty things.
So we saw last time we booked a flight, there was kind of that cascading effect, reserving the seat, making the offer price, confirming your reservation, deducting the account, and finally printing the itinerary. So if we actually look outside the JavaScript here, we see a series of doesn't want to do page down. We see a series of events, basically, where we go ahead. The very first thing we call is hold seat, which makes an Ajax call to holding the seat. Once that's done, as long as the results were okay, it goes ahead and makes the offer. It grabs the bid price and contacts the make offer web service. It then proceeds to get the callback from make offer and says, okay, great. As long as everything was still cool, let's actually book the seat. And then it comes down here to booking the seat, and everything's all done. And then finally debiting the account.
And another really easy way to see this is if we come back and use it. Did we do it?
Just make a bid.
We'll make a bid, and we'll see every request that's getting made through XHR. We're seeing here in Firebug again. So we called hold seat, book flight with book seat, book flight debit account, and we're done. So there was this domino kind of effect. Now why did we do this? So we wanted to make an Ajaxy application. This was, again, everything we see here was advice we got from someone else. We wanted to do this because potentially this is a long-running operation. Maybe booking a flight takes 30 seconds while it goes out and checks all the partner websites or whatever. You couldn't just have the user sit there on an empty screen for 30 seconds. So we made it Ajax. We made it able to give you lots of feedback, lots of little steps. So you get a small step and some feedback, a small step and some feedback, instead of having to wait. This is a very Ajax-y type thing to do.
Right. It's interesting. Ajax apps are kind of a combination of thick clients and thin clients. They're not just dumb terminals like your standard web browser, talking to Google, but they're not really a full-blown desktop app that's maybe talking to a couple of attached server resources. It's kind of somewhere in between, and where your app code ends up is very interesting. So in this case, I went ahead, I put a breakpoint, and way down in it, I'm making the $50 bid, the bid's accepted, booking it, and then right here I'm in the debit account function. And we're just going to alter the data. We're going to say, you know what? The amount that we're going to give them, it's no longer $80. We're only going to pay them $1. And actually, that's a string. And then let it continue. And if we actually look over here, we'll see, making the bid for $80, they're accepting the bid, but by the time it actually gets to debiting, it was only $1.
Now, you may be familiar with this kind of attack before. There's a very, very old traditional web application attack called client-side pricing. Everybody?
Yeah, everyone knows.
And the way this was usually exploited was that you'd have a shopping cart or something, and that the order prices or the order total was kept in a hidden form variable on the page, and then the server would just accept that back from the client. So it wasn't just hidden form variables. You can do it with any kind of client-side state mechanism. So cookies, anything in the query string. Mm-hmm. Now, this is the exact same type of attack, but it's coming through with a completely new vector because of Ajax. We're using JavaScript to store the client-side state now. Now that we have partial requests and page down modification in the response, we can keep those server API responses in JavaScript variables. It's state like anything else, and when you keep it on the client, it can be manipulated by an attacker.
Now, this actually, it's an interesting twist, because if you think about traditional web apps, right, it's almost like batch processing. I fill out a form, I pop that form, maybe it fires off a post to a web service, and at that point, I've given it my input, and I can't tamper with it. And the way you break web apps is you try to give it really malformed data and try to make it break. It's a black box. I have no idea what it's doing. It could be contacting multiple database tiers, different application tiers. It could be, doing an XPath query for all I know. I really have no idea. But now, because part of the application is existing on the client, I have the ability to actually tamper with data while it's being processed. So in this case, it went ahead and said, yeah, $80, I'm totally cool with that. But by the time it came back to actually debit the account, that value had changed. It would have been impossible for a web app, for an attacker to do this in a traditional app unless they had some other type of vulnerability, code execution, where I'm able to actually manipulate the server.
And continuing along those lines, not only can we manipulate the data that we're sending to the server, we can change the calls entirely. We can choose to send functions out of order. We can choose to not send functions at all. So let's demonstrate.
So we saw that right here, when we actually book the seat, we're calling this web service, book seat, passing the username and flight. So why don't I just call book flight? I mean,
what we've done here is
directly.
There's a server. Basically, when you're using Ajax, there's basically a server API. You're using your client to contact your back-end API, and you're trusting that the client is going to call it the way you intended it to. But as we've said before, and I'm going to continue to say, this is simply nothing you can control. You can't force the user to call that API in the manner you intended. So we're going to call the really interesting parts of this, which is to book the seat, but then leave out the less interesting parts, like actually paying for it.
So I'm going to call the web service directly, or call the Ajax function, which calls the web service, and let my callback be window alert. So it's just going to pop back whatever the raw response is, which should be like a JSON status message. So I'm just going to call book seat. Okay, it's book seat a couple of times. It's asynchronous, which is always fun stuff. So let's refresh this. How many itineraries do I actually have booked? Oh, well, I'm on a lot of seats. Now, this is interesting. I'm sure a couple people cringed. I saw Beetle actually do it. When he saw that, when we made the low bid and it said holding seat, because the last thing you want to do when you're in a checkout procedure is have somebody else have a race condition and have somebody else come along and snipe the seat. And don't get me wrong, we'll get to race conditions in a minute. Those are fun too. But when he rejected our offer, they then released the seat. Well,
by a manual explicit call.
Yes, by a manual explicit web service call. So what happens if we just start calling book seat? or hold seat, and never actually call reserve or release seat. Well, we can perform denial of service attacks extremely easily. And these aren't your standard denial of service attacks where, you're doing a SYN flood or a Smurf attack or what have you. You're not flooding it with traffic, right? You could never DDoS Google. But you can DDoS Google Maps or you could DDoS Google Docs and Sheets by actually what we're calling a control logic DOS. We're going to go ahead and actually change the order that functions are called in, pass them invalid data. Maybe we'll do a race condition where we call this first function, and the second one, which is dependent on it, we'll let them both go at the same time. See what can happen.
There's all kinds of possibilities here. Anytime you have a resource allocated in one function and then freed in another that you're calling manually and explicitly, you have the possibility for this type of denial of service. Consider maybe opening a file handle in one method explicitly and then explicitly releasing it in the next. Again, easy just enough to call it and open it and hold it that way so that no one else can ever access that file. So, very effective denial of service.
This is actually, I know maybe some of this sounds contrived, but again, this is all stuff we've seen in the wild multiple times in our pen tests and in looking at actual customer advice in these various books. So I'm going to go ahead and I'm just going to start calling the hold seat. What trip was I booked on? I was booked on. Let's call that first one. So hold seat. And if you also think about this, right, this whole concept of we're going to allocate in one and get rid of in another. A lot of people probably are thinking that's really bad. All these web services should be atomic. But if the web services are being atomic, that kind of gets you away from what AJAX is supposed to do, which is break complex operations up, have the client actually be involved in a meaningful part of the application.
Right, and now
reduces feedback.
You have the user just sitting there again for long, potentially 30-second long operations. This helps you make mashups too.
So window alert, okay. It has a random number of. Oh wait, there it is. All right. So error available seats equals -1. So let's say even your developer was smart. We've now exhausted all of the seats, and in fact, if we do a search right here and go back, we'll see that all of the seats have been exhausted for the AirTran flight. Now, the interesting thing here is even if your database guy or even if your developer was smart and he wrote something and said, you know what, let me have a cleanup thing that after 30 seconds I'm going to go ahead and close that database handler. Now you're talking about however many outstanding flights there are. Let's say there are, 8 outstanding seats on the flight. I need to send, don't need the breakpoint. I need to send 8 requests to go ahead and grab those things and hold them. And then once every 30 seconds, as each one of those seats becomes available, I have to send one more HTTP transaction. Yeah, so here we see the AirTran flights has 0 seats available. So that is a ridiculously easy DOS. It's amazingly asymmetric, right? I got to send one HTTP request every 30 seconds, and you can't book a flight on a plane. How many millions of dollars will Expedia lose in a day if I do that? I'm not suggesting.
Hackervacations.com.
Yes, Hacker Vacations. Yes, we're talking about Hacker Vacations here, nothing else.
So let's at this point let's keep looking at the code and find out what we can do. I mean, we've done some pretty serious damage so far. We can not pay for flights. We can basically DOS the plane. Let's see what else we can do.
So, an interesting thing here I just want to point out is that there's always seems to be this file called common.js. And in fact, right now, as you all can see, I'm on the itineraries page, right? This involves no user feedback. This is purely a informational server. Everything is actually processed on the server and it spits out the flights. It's not Ajaxian in any way, shape, or form. But it's got a JS file with all of these random flights in it. It's got the functionality for doing flight searches. Our bidding page, which only does bidding, had references to flight search. I can do the make offers. So it's actually exposing the API, the entire API of the application, even when I'm on a page that doesn't use those parts of the API.
And this is not surprising because again, this is advice we got from other sources, which is to keep all your JavaScript in one large monolithic file. Well, it's actually, from a certain perspective, good advice. It's easy to maintain that way.
It caches once.
Yeah, exactly. So it's good for performance. If you need to make changes, you're making changes in one spot instead of multiple spots. So on the surface, it seems like good advice.
It also seems like they might be using a template. So if you use ASP.NET, master pages, if you're using PHP, Smarty or ITX. So if we actually examine the source of these two pages, we'll see that the head is almost identical. I've got this JS file. I'm including JSON.js for our transport. The location of where the style sheet is, the white space, everything is exactly the same on this. So what the developer probably did is created some type of template, and in the head, obviously, he referenced these JS files. So since we've been able to DOS the plane and go ahead and manipulate the control flow of this application, let's try to see if there are any other web services referenced in Common that are providing functionality for a part of an app that we haven't seen yet. So let's go ahead and start digging in. Way down here. Those look kind of funny looking. There's a JavaScript function here called crypt. We'll look at that in a minute. Something else you should never, ever do in JavaScript. Okay.
So we've got things we've seen here before. We've got
Flight
flight search and make offer, book seat, debit account, hold seat, release seat.
Miles club check.
I'm not sure we've seen that one. Admin.addUser. That's really interesting.
Well, I didn't see an admin page. Did you see an admin page?
No, I sure didn't.
You know,
we could probably just randomly look for one. We
I'll
could
tell
do
you
maybe
what,
like
let's
a forceful browsing kind of thing.
I mean, I'm not trying one. I could use something, if I was going old school, I could do LibWhisker, or I could use an excellent SpyDynamics/HP product. But anyway, I could enumerate these things and try to find all these, try to find this admin web portal, which we see references to.
But why bother?
I know what web service it's talking to, right? Think about what we've seen on this site. We've seen that it uses AJAX. We see it's calling a method called doPost. So I think it's probably safe to say it's using HTTP post.
And everything we've seen it send so far has been JSON. And in fact, it says it uses JSON as the parameter name. So let's just try to call this. Now we don't know exactly what we're sending it, but we can send it just maybe an empty JSON array to start and see what we get back. Maybe it'll work and then we've won, or maybe it'll come back with an error and give us some more information as to how to proceed.
So let's go ahead. I'm going to fire up. And again, there's nothing honestly magical about spy tools. You can do this with Paros, Proxy, Fiddler, whatever floats your boat. So let's just throw Hacker Vacation in. And what was that?
I believe it was
AJAX calls add user.ash.
HX.
Oh, thank you. HX. We know that it was a get, or excuse me, we know that it was a post. And we know that it's probably taking JSON of some kind, but we're not sure. So I'm just going to put in
an empty array.
Empty JSON array. Y'all know what JSON is, by chance? It's a kind of a lightweight data transport, not quite as heavy as XML. Interestingly enough, JSON is actually a subscript of or a subset of JavaScript. And the way you eval JSON when it comes back into JavaScript makes for some interesting cross-site scripting vulnerabilities, especially if you're using Prototype. So let's go ahead and send this sucker off, see what we get. And we get back 200 OK can you all see that? With a nice verbose error message that says
missing username, missing name, missing password, and missing debug flag.
I don't know about you, but debug flag sounds like something that would be fun to mess with. So let's go ahead and put something in here. I'll just do, Eve is always good. Eve. And let's see if we can actually change anything that we're getting back here. Maybe that's just a generic bad formed. And we see the error message actually change. Now it's just saying we're missing a name, a password, debug flag. So let's go ahead with put in a real name. Now for password, it's interesting, right? I mean, we might just be getting this error message because we don't have the right number of parameters. We might start getting things about this isn't the right password strength. And because we're not actually accessing it through the admin portal, we're literally talking directly to the web service. We might miss knowing what basically the rules are for these inputs. So we're just going to try to guess.
But they are giving us nice verbose error messages, so that definitely helps us. But even if they weren't, we could get past this.
Eve's password is going to be unimaginably Eve123. And debug flag.
I think we should do debug. That sounds pretty
true. Yes, let's do some debug. And again, I mean, I'm assuming this is going to add a user of some kind, but again, we're flying blind. But we found a reference to it. So let's go ahead and send, and we get invalid value for debug flag, which is interesting because we're on the right path. We don't want to try false. Let's try it in quotes.
Definitely try it in quotes.
What? All right, let's try one. That sounds good. Send. Success equals true. Okay, so did we actually just create a user? I don't know. That would be kind of cool if we did. So let's go ahead, head back over here. Let's log out of Hello Spy. Log in as Eve. Eve123. Log in. Wow, that sure looks a whole lot different.
So apparently we added a user and we've got extra things to do. We have a debug menu. toggle ads, set the date, load transactions.
Dump log sounds cool. And we see some information down here. We've got a load balancer, a big IP load balancer, some uptime.
And this is interesting too, a return to admin link. So apparently they're figuring we're an admin type user and we're going to go back to the admin login page now.
But the weird thing is we didn't get here from an admin page. So that's a little odd. So let's check it out. And we're at an admin portal. And sure enough, it's located as site config index HTML. So we probably would not have guessed site config in maybe the 800 directories or whatever that we enumerated. And incidentally enough, we've got a null pointer exception or an object reference not set. Again, probably because we're not really an admin. We're not really supposed to have been here. We've got the app kind of in some weird unstable thing.
Now we can try to break into it at this point. But again, why would we bother? There's no reason for us to do this because everything we can do on this page, we can already do through the exposed API.
Exactly.
Even if we had managed to guess this page before, if we'd guessed site config, we would have had to try to brute our way in or inject our way in or whatever. And who knows whether that would have been successful or how long it would take. So the site people or the site developers did a really great job of locking down access to that page. That site config page was totally secure. We couldn't get into it. But everything that site page did was already exposed that we could just call from another site. So we just kind of snuck in a back door, if you will.
So the problem is that they're not actually putting validation functions or authorization, checking authentication or authorization on the actual web methods. What they expected is that the admin user would hit, admin.php, whatever. They'd already performed the operations there, and then there'd be Ajax and JavaScript on the admin portal, which is actually contacting these web services. And it's kind of this whole concept of, well, why would anyone ever use the app differently? I mean, this is the JavaScript I gave them. There is no JavaScript which makes a call to this web service. How could the app be used in this way?
Now
We've actually had developers say that to us.
Just like we saw before with the pricing attack, it comes down to calling things in a way that it wasn't intended, or things that may have been, when this was a traditional web application, when this wasn't Ajax, this was probably okay. There was no way just to directly call that method.
Right. We actually, we'll show you one that we actually got from a code test here. Where'd it go? This is actually a real-world example. We found this about a year ago on one of our first Ajax assessments, where this is a web method.
Yeah, this is one of my all-time favorite real-world examples here. So we have a method called update password that takes a customer ID and a new password and just accepts that blindly. So, we missing anything here? Maybe an old password to confirm that you really are the person who knows the old password. When this was, okay, so bonus points for anyone else who can find other vulnerabilities in this code. SQL injection.
SQL injection.
Anything else? Cross-site scripting, exactly. So what we have here is a method that anyone can call directly from a web browser, from a client, that will change everybody's password in the system to anything they want, and then cross-site script them again on the way back out.
And SQL inject. And just look at this. This is 5 lines of code, including a return statement, and you have 3 vulnerabilities in it. A giant DOS of everyone on the system, SQL injection, so there's no point in setting them to gibberish passwords. You can just take all their data anyway, and then, kind of cross-site script them and smack them on the butt on the way out.
So this is about the most vulnerability-dense code we've ever seen in our entire lives.
Now, again, this is the difficulty, right? Because y'all are laughing. Developers don't get this, because this is what developers see. Developers, on the left, that's your traditional app. You basically, again, it's that whole batch processing point of view. I'm going to give you some data, you're going to process it. It's going to contact inside that box, database tiers, different types of servers, everything. We actually have no idea what it calls. And you know what? This was probably an app that used to be a traditional app and got converted.
Right, and when it was probably, I'm not going to say secure, but a whole lot more secure than it is here. Go back to that for a second. So presumably this was executed as part of a multi-stage process, and the first stage would be to authenticate the user, make sure he really is that cust ID, make sure that he really does know the old password that matches up, make sure he's doing some whitelist input validation on these cust IDs and new passwords, make sure that there's no cross-site scripting on the way back out. So if this was executed as part of step 4 of a 10-step process, it was probably okay. But then when they said, hey, let's just slap some Ajax on this app, and throw this up to the client, it became monstrously more insecure.
Exactly. What a lot of people, they're there are actually companies that sell products where they say, we'll Ajaxify your app in 15 minutes. Personally, I'm kind of a little uncomfortable with the phrase Ajaxify.
Yeah, we like Ajax.
Sounds like something you pay about $30 for at a spa. But, I mean, you've got all these things that are basically getting pushed to the perimeter. And you have these web services you can contact directly from JavaScript, in addition to all these, like we're talking race conditions, things like that. Actually, do you want to talk about race conditions?
Yeah, I think we've got a little extra time. So we talked about the problems with asynchronicity. So the asynchronous is the first A in Ajax. And we talked about a deadlock or denial of service. But a race condition is another really serious possibility. In this example here, we have a web service or a back-end service with two methods. And the first is add item to cart, and the second is checkout. So this is a very simple service. So the first item, or the first method first calls add an item to the order, and then it updates the order cost. And this checkout debits the account and ships the order. Now, when this is executed as intended on the client, the client is directed to wait for the return from add item to cart before checkout becomes available.
Again, this order is enforced in JavaScript. It's in the callback function.
Right, but as we know, you can't enforce anything in JavaScript on the client. So what we're going to do now is we're going to, instead of being really good citizens and waiting for add item to cart to return, we're going to call checkout a millisecond after add item to cart is called. So what happens is all the back-end functions mesh together. Instead of being called in the order 1, 2, 3, 4, you can actually get it to order 1, 3, 2, 4, which means first we add an item to the order, then we debit the account, then we update the cost, and then we ship the order. So basically anything you added in that last add item to cart, you got for free.
And these, I mean, quite frankly, are extremely hard to detect. I mean, as anybody who's ever tried to debug a deadlock or a race condition in a multi-threaded app,
it's hell.
It's really difficult. And it's also, developers, again, they're QA testers, right? They're not pen testers. QA people, maybe they're throwing a single tick into, a text box and clicking submit. But they're not actually digging into JavaScript code and realizing, let me start calling these things out of order. Let me start manipulating and changing how this app is supposed to work.
Yeah, that's a really excellent comment on how unbelievably difficult Ajax applications are to test. So not only, you can't just sit down and use the app in a web browser. Now you can have the best tester in the world, check every different possible combination. Like
Howard.
Let's go back to the application.
All right.
So we've got a page here that has flights from and flights to. And maybe there's 100 items in each of those combo boxes. And maybe we say, we're going to check every single one of these to make sure they all work. So every possible combination of the two cities. You could do that by hand and it would take you hours, or maybe you set up a script to do it for you, and you say, okay, I have exhausted the possibilities of this application. I've tested everything. I've tested every possible input. Well, no, you haven't. You haven't even begun to test every possible input. All you've done is test what you can do through the browser. There's an infinity of possibilities you can send. You can send anything you want.
Which reminds us of another comment we actually got while in the field, where, I kid you not, an HTML developer, well, I don't even want to say that, that's kind of an oxymoron. A developer was telling us, what do you mean? It's a drop-down box. They can't put anything else they want in there. And I'm like, are you kidding me? Of course I can. And so I showed them, everybody here use Web Developer Toolbar for Firefox. It's got all sorts of things like, make text boxes or make drop-downs into text boxes, change 4 methods from post to get. It's fantastic for doing things you should not do. So like Brian started to say...
Let's continue on that then.
We've only talked really about, it's not that we've been using the application as it's been intended, right? But we've been manipulating data inside the context of the app, right? We changed some constants. We put a breakpoint in and changed the value of a variable, the offer amount, while the app was still processing on it. We've done some race conditions. But what about this increased attack surface, right? What happens if we start doing SQL injection attacks or cross-site scripting attacks against these endpoints?
Yeah, and here's another really good observation in that a lot of the stuff we're talking about Ajax is kind of new, maybe. Well, like a race condition or a deadlock isn't new, but we're talking about it in new ways. But let's try some of the old school stuff. Like SQL injection is an oldie but a goodie, and it's going to work just as well or better in Ajax than it does in a traditional web application.
Because there's a lot more places I can SQL inject. So
now, a lot of people will say that the added attack surface from Ajax does not come from the architecture of Ajax, but rather the added functionality.
Those people are trying to sell you consulting services. We're only trying to sell you a product. So we screw you once, they screw you repeatedly. So right here, we see the kind of the classic unclosed. In fact, no, let's finish that thought, right? I mean, we're not trying to actually make a joke here. We're being serious. In this app, we saw all those individual functions got called. You know, hold the seat, check the reservation, debit the account, print the invoice. All of that stuff happened in the server, right?
And this was going to happen anyway.
Yeah.
There's no additional functionality here.
All we did is just move some of those things in the order they were called in to the client, so that there was more feedback. So app, no additional functionality. It just books flights. But you now have, 4 or 5 more web services, little places you can put your fingers in and try to attack it.
Every one of those parameters on every one of those methods has to get secured, just like every form input does, just like every cookie value does, just like everything else. It's just another input that has to be secured.
Now, actually, we were talking about QA testing before, right? You'll notice in this JSON blob here, there's something called employee discount equals 0.
Now, we didn't see any UI or a little checkbox that says I am an employee and should get a discount.
So this is another thing that QA people are going to miss, right? Because what happened is JavaScript is intercepting the events. We're no longer a dumb client, right? Writing web scanners, it's by no means easy when you start getting into state-keeping mechanisms and things like that. But you're basically writing a user agent. It's going to throw data at the server and look at what comes back. But it's more complicated now. You've got JavaScript, which is going to trap events and then generate its own requests. And in this sense, it actually created a new input, this employee discount. There is no text box, there's no hidden input field, there's nothing there. It exists purely in JavaScript. So if you're doing a fuzzing or you're doing something without actually analyzing the JavaScript and seeing what it's doing, or actually trapping requests at the line level, nobody's ever going to see this. No one's even going to know to test this.
Now let's keep playing this SQL injection out, because this definitely has some possibilities.
Now remember when we actually sent the request as usual. Oop, got to change content line. When we sent the request the way we were supposed to, we got back that nice big blob of XML.
Yeah, let's check it out.
Yeah, let me send it normally. Y'all are kind of quiet. Do you have any questions? Yes.
We'll get to that afterwards.
Brilliant minds are working on it. No, we can talk to you about that. So
we get back this nice big XML blob. So we've got flight IDs and origin cities, death cities, pretty much everything we need. Go ahead.
Well, what I was going to say is, right, a lot of people like to have this is data. This isn't HTML, right? So normally what we would do in a traditional app is submit some data. It would process, format everything, what we're calling, say, data binding or data formatting. Take those database rows and actually make a nice, sexy, cascading style sheet, liquid W3C compliant, geek sheet crap blog and display it. So, it actually renders it to HTML. But here we're getting back a big block of data, and we're relying on JavaScript to basically, like we saw, parse the XML, walk this tree, and actually build into the DOM the response.
Yeah, this whole issue of data being transformed into HTML has got to happen somewhere. We can't just display raw XML to the user. So, like you said, traditional web app, this is going to be done on the server. But now with Ajax being done on the client, again, this is advice we got, and it's great advice from a performance standpoint, because XSLT and operations like that are very expensive operations. You don't want to do that on the server. You want the client to handle his own transformation.
Essentially what's happening here is that the server is basically acting as a proxy. It's going to say, let me contact the database tier and pull any information you want, and let me just forward it back to you. Maybe I'll wrap it in JSON, maybe I'll wrap it in XML. It's not really aware of the data it's pulling out, and more importantly, it's not running through saying, let me take the first column of the first row and, put it in the head of a table. Let me take the second column of the second, and iterating through like that. It just forwards everything back down to the client. And so you have this great ability to do basically just a few injection attacks and dump the entire database.
Yeah, we're getting just a little ahead of ourselves here. So back here, we're going to try this. We're going to just throw a tick in there and see what happens. And
we saw it.
We did see it. We got back an error message.
The lovely unclosed.
Yes, unclosed quotation mark.
Yes.
So right away we say, great, we're potentially vulnerable to SQL injection, and let's play this out. But let's play it out in a traditional web app environment. What would we do? We would try to do some union selects on the sysobjects table maybe, and that's kind of tedious. Union select is not the hardest SQL injection to pull off, but it's definitely not the easiest. You've got to match up all the column names, you've got to match up the types.
You got to cast to get error messages.
It's a little tedious. And now let's assume that the web server wasn't being so generous with the verbose error messages and was just giving us back like generic error pages. Well, now what are we reduced to? Now we have to do blind SQL injection, and that's unbelievably tedious. Now we're going to be sitting here for hours or more, or trying to get a tool that does it,
or eating popcorn while Absinthe does it for us.
Right. But and now again we're making thousands of requests. We're saying, is the first character of the first table less than n? Is the first character of the first table less than d? And there's a huge chance you're going to get caught at this. If you're making 20,000 requests to get information out of a database, you're going to get picked up by the IDS.
Exactly. So what we're going to do here is just piggyback a query on top. You know what? We'll just see what happens. So let me change the content length. Let's go ahead and fire off a send.
So since we saw that we were getting back raw XML from the server and not HTML, we get this assumption, we get this idea that maybe the data binding or the transformation is being done on the client. And if that's the case, then there's an excellent possibility that the query we're sending is just being passed through to a back-end database or XML document, whatever, and the results sent back plainly uninspected back to the client.
And here we see it's the case. We see right here that we had flights, users, and trips right here are appended. We see this is all these are all rows from the first table, just table without a number. And, flight numbered, origin, carrier, all that. And then suddenly here's the results of the second query that we piggybacked. Select flights, select users, select trips.
So how easy of an injection was that? All we had to do was append, select star or select name from sysobjects. We didn't have to try to match columns. We didn't have to try to match types. We didn't have to do anything. We just said semicolon, add our next query. And now let's just go pull everything out that we just saw.
Let's do true. Now, obviously, this is requiring a backend database that supports multiple queries. So if I'm doing PHP and I've got the SQLite plugin, and SQLite doesn't support two SQL queries in the same SQL statement when you try to execute it. So it won't work. But where it happened, obviously, they didn't really make an attempt to hide that they were using ASP.NET and IIS. Here.
Yeah, and one of the databases that is vulnerable is SQL Server. So I think that's a pretty widely used one. So we're going to do select star from trips, semicolon, select star from, what were the other ones? Users, semicolon. We can keep doing this all day. If there were 50 tables, we can just keep appending all the queries we want.
Select star from flights.
From flights.
And kill the where clause.
Kill the where clause.
Update content length.
Thank you. And we're going to send this.
Ooh.
No, we missed something. Oops, semicolon.
Is that going to matter?
No.
Well, we can always read the error message. It's verbose.
That's right.
All right, let's see what it is.
What do we get? Okay, it's not flights.
Oh, it's flight. Sorry.
Okay, got our 200 back. Now, here's all the data in the database.
There's the flight data. And then we're actually down here, we see table 1 is starting, and we're actually dealing with, user ID, admin. We're seeing Sam.
It looks like some password hashes.
Chesty LaRue. Eve. So yeah, there's Eve, the debug, and notice debug flag equals true, so we added her to the database. Here's the flight information. So in a single query, we jack the database.
So how long would this have taken us with Union Select? How much longer than that would it have taken us with Blind SQL? And we did it in 2 queries. Now, two requests to the server got us the entire database.
Now, obviously, the underlying problem here is SQL injection, right? The only problem is that where you're doing the data binding increases the damage and how quickly you can do damage with the SQL injection vulnerability. So we want to be very clear. This is kind of an odd edge case. It only works on databases that support chaining of SQL statements.
But actually it expands just beyond SQL.
That's true.
If you're using an XML document as a backend store, and you're using maybe XPath or XQuery to query that document, this is very vulnerable to XPath injection attacks. And in fact, XPath injection attacks are even easier to pull off than this one we saw here. Where this one took us all of 2 queries. You can actually fetch the entire XML document with 1 XPath injection attack.
XPath is so much more forgiving of poorly formed statements.
It is much more resilient. So in SQL, if you select a table that doesn't exist or a column that doesn't exist, it will just fail and give you an error. But XPath, if you throw junk into there, it'll just say, well, that doesn't exist, so I'll give you back nothing. So you can say, give me some junk, cat with everything, cat with more junk, and it will just give you everything. Very, very easy. So your whole XPath injection is pipe/*pipe, and that's the entire document.
So again, just this example or this diagram kind of helps things out. What's happening is your SQL injection command is still piggybacking on top, right? That in your traditional app, you normally have to do like a union select to try to basically interface the results from the second query into the query that's already existing in the back-end app. Here we're piggybacking, right? I mean, this would work. Even though the results, when the server's trying to format them to XML, it's not actually forwarding the results through, I'm still executing SQL statements. So you could do the whole lovely, you see a site with ASP. I know I always like to do semicolon shutdown with no wait. And then the database, or then the website stops responding, and I'm really glad I'm using my neighbor's wireless connection. So you're still running SQL commands, right? But you can't get the data out because the server is basically quelching it. But when you're binding on the client, the data's still going across the wire. And then JavaScript may suppress it, may put it into a table. Maybe it doesn't. Frankly, I don't care.
Because
it's on the wire.
We've already won at that point. Any smart hacker is going to be listening with a proxy or a proxy tool to see what came over the wire. Now, what are some of the design implementation patterns that lead us to this? A very common one is the use of the ASP.NET dataset. Actually, Microsoft recommends use of the dataset to return query results to the client. And I really hate that for exactly this reason. Dataset, no matter how many tables you fold, or how many select statements you fold into that query, dataset will happily just keep adding more tables and more tables to that dataset. And then when you serialize that to return it to the client, it just gives you everything. It makes it very easy to pull off this kind of attack. Another really common one is the use of the for XML clause in SQL Server. Again, you can keep tacking as much stuff as you want on there. Say for XML. Just gives it all to you. We talked briefly about XPath, so those are the big ones. Sometimes if you're binding, if you're binding your data by index instead of by name, so in a traditional web application, or if it was binding, if you will, on the server, you'd say this part of the page is record set bracket customer name, record set bracket account number, and you'd be pulling the exact thing you want. Well, if you're binding it by index 0, index 1, there's a better chance that someone's going to be able to inject their own statement into that and take over.
Right. So let's go ahead and move on to the next step. Do you want to talk about symptom chat?
Yeah, I think we're there.
Okay.
So again, all of this everything we talked about today came from bad advice. So what are our symptoms, if you will, of premature ajaxulation? We talked about sensitive state being stored on the client. We talked about control flow manipulation, exposed administrative functionality, and really not just administrative functionality, but just exposed functionality in general, things you're not supposed to see. And then finally, increased susceptibility to injection attacks.
Now, certainly some of these things, like a lot of people like to say, okay, well, storing secrets on the client, everyone knows you shouldn't do that, right? But before Ajax, you were pretty stupid if you somehow ended up with a database connection string in JavaScript, because JavaScript can talk to a database. So what's it doing there? Normally it was in a comment. Normally it was in something that got left over. Maybe there was a, HTML comment with a username and password. But because JavaScript can play such a more meaningful part in the application now, developers are tripping over these mistakes that we in the security industry have known for a long time are really bad. Because it's so easy. Look at things like Silverlight. I mean, this isn't Ajax, right? But Silverlight is Microsoft's, supposed flash killer. You can write both the client-side part of the code that actually runs inside like a Java applet and the server-side code in C#. The class names are the same. In fact, when you're building it in the little GUI, it's very difficult to figure out which code is going to end up actually compiling and running on the client and which code ends up compiling and running on the server.
Yeah, one of the things we've always said about Ajax is that it adds this additional layer of complexity because you have to have the client and the server I mean, generally running different languages. Not too many people use JavaScript on the server side. So you'd have to know the language conventions of Java or PHP or whatever you're running.
We should tell them this. This was funny. We had one of our customers that we were doing a little review for. They kept having all these weird error messages. They're like, some of our orders aren't coming out right. They were running Cold Fusion on the back end and JavaScript on the front end and doing AJAX calls to Cold Fusion. Well, Cold Fusion uses 1-based indexes. JavaScript uses 0-based indexes. Doesn't really seem, I mean, that's kind of a little nuanced. Nobody really cares. The way they implemented their shopping cart, they were actually passing array indexes back and forth. So you could check out and pay for, the 14-karat, cubic zirconia engagement ring, but actually end up with a diamond ring instead. I kid you not. And these are things, right? You would think nobody would do this. But again, when it's on the server and it's all one language, it never really came up.
So then we said, well, wouldn't it be great if you could have the same language on the client and the server? Well, then Microsoft came out with Silverlight, and now basically you can. But all that did was open up a whole different level of stupidity on the developer's part, or let's say ignorance to be kind, because people can't really tell what's executing on the client and what's executing on the server anymore. You see questions in blogs like, how do I access my database from the client, or how do I access the database from the client? Well, you don't. That's insane.
And even if you could, shame on you for wanting to.
Yeah, absolutely.
It is. In some regards, though, it depends on the app, right? Google Gears, I've done a whole lot of work. In fact, Brian and I are going to pimp it later, but we've got an AJAX security book. We've got an entire chapter to offline AJAX apps. These scare the crap out of me. Let me get this straight. You want to write an application that has so much of its business logic in JavaScript that the application works when you're not even talking to the web server? Are you crazy? Not only that, actually, but Google Gears has a local SQLite database that's accessible from JavaScript. So suddenly, client-side input validation is important again. Because when you're in offline mode, you can SQL inject the database, or someone could SQL inject you. Cross-site scripting. If you're not actually performing validation in JavaScript in an offline AJAX app, you actually can have security vulnerabilities, which we never had before because the client couldn't do anything interesting. It was just a dumb terminal with maybe some simple regex checking for a form.
All right, so we may have strayed away a little bit, but yes, it's possible to make good AJAX applications, and we do really, really like AJAX. We think it's got a lot of potential, and I guess we spent the last hour or so scaring you guys. So let's give a little advice as to what we can do right.
Let's just run through this real quick. Where did we get some of these? AJAX design patterns is very scary, very cool. Smart guys that wrote it, not too smart on security. This whole concept of having business logic on the client is their fat client design pattern. And in fact, they say things like, don't put business logic on the client. But every one of their examples does it. And a lot of the other things they show you how to do presuppose that you have business logic on the client. So it's like there's either a major communication problem in the AJAX community, or they're just kind of talking out both sides of their mouth. AJAX design patterns, this control flow manipulation, is distributed events. Now, granted, you could do this in a traditional web app, right? Maybe there's a multi-step process, and you're going to go ahead and make a post to step 2 in the process without making a post to step 1. Well, it depends. They might be keeping something on the server that says, well, you can't go to that step, in which case that would stop the AJAX thing too. But you might not be able to even see how many steps there are. At least in AJAX, they give it to me all in JavaScript. I know as soon as I hit this one page without having to probe around and find out how many steps there are in this process, I know exactly what the control flow is. I know what inputs are used from previous calls and later calls, all of that.
And the other things we already talked about briefly, the single JavaScript library for ease of maintenance, which exposed the administrative functionality, and the ASP.NET AJAX people telling developers to return results in data sets.
So it really comes down to who do you trust on this stuff, right? And we like to say trust us. I'd like to think that we're not complete morons. I mean, sometimes we're kind of silly, but, what resources are you going to use out there? This stuff's 2 years old. We used books. We used blogs. I have for the last 2 times, I'm going out again in September, to speak at this conference called AJAX World, where it feels like I am one speaker out of 70, and I'm on a stage talking about security, and 69 people are talking about how to do the most insecure applications possible. This conference has a magazine, which is a pretty good magazine, AJAX World Magazine. They've got a lot of code snippets and advice about how to build, sexy drag-and-drop shopping carts. So I'm sitting there waiting to give my presentation, and I'm looking through this, and I see, all of their code samples have massive security vulnerabilities in them. And so I get up, introduce myself, and I just start for the first 10 minutes of my presentation. Will you please turn to page 76 in your Ajax World magazine? Look at line 13. This is a file disclosure vulnerability. Here's why. And everybody there, right, all these Ajax developers are like, SQL injection, file disclosure? What is this? Tell us about it. Because, right, we've been able to kind of get some web developers understanding security, but things like Flickr, things like, what was it, Delicious got bought, MySpace got bought for how much? Facebook wants $2 billion. There's so much money in the air. You have people who don't know web security don't know web development, moving into web development. And things like ASP.NET, Java, J2EE, people who have written desktop apps can go, all right, show me the equivalent of a grid view. Now I can write a web app. Yeah, you can't. The security paradigm you use and the way you do things on a desktop app is different for a web app. If you find a file, or if you find a buffer overflow in the find dialog of Word by throwing in 8,000 pipes, no one's going to care. Because it's not remotely accessible. Who would, buffer overflow themselves to run code as themselves? But if I find a buffer overflow in the, spell checking or the, file saving mechanisms of, say, Google Documents and Sheets, I'm running it on the server, and I win. And these people don't understand that.
Another issue, let me go back. Another issue would be like the frameworks you use. Like hardly anybody actually rolls their own Ajax framework. You're going to just go out and pick one. But now you're kind of at the mercy of that framework. And some are better than others. A good example, I'm not going to pick on them too bad, but the Direct Web Remoting framework has this one feature that it's like a test page for your application. So everything you can do on the server, every API method you've exposed, all you have to do is, if you have the name of the application, just append /DWR to the end, and it takes you to this test page where you can actually just call everything there is to do. Not only is it telling you the complete attack surface of the entire application, it's letting you just exercise it right there in a really convenient test page. Now, granted, you have to have it in debug mode for this to be turned on, but I mean, how many people accidentally deploy their applications in debug mode? It happens all the time, and it's a huge security hole.
So actually, I wish we had more time to devote to frameworks. Zane Lackey and Alex Stamos at ISEC Partners, they've kind of been, doing the circuit, doing a really good presentation on this. They basically ripped DWR, a new one. They attacked Prototype. There's a whole lot. The Fortify guys did a pretty good attack against some of these, actually Ajax endpoints. Jeremiah kind of pioneered that about a year ago. So, there's a lot of interesting stuff out there, and the frameworks are just kind of starting to understand security and not really doing it right. There's no way the end user, the end Ajax developer understands it.
There's one more really important point in that when you take things like this and use it to cut down any unused methods to reduce your attack surface. So there was another really good example in that there was a college that had made an Ajax webmail type application, and they just took it from, it was SourceForge or wherever it was, just as is and piped it in. Well, if you look at the exposed server methods, which was easy to do just by looking at the JavaScript, you'd see that there were functions like invite new user. Well, this is pointless for a college website because everyone who should have an account already has an account. So again, this is probably an unused function that would be vulnerable if someone were to try to call it.
So, this whole concept, don't store secrets on the server. We didn't have a chance to show it. This actually came from a Macworld hack. And in fact, SPI runs a user conference each year. And a couple of months ago, we noticed that the third party we were using to actually register had basically client-side pricing. It wasn't. It was client-side pricing through JavaScript. The exact same thing we showed you earlier about being able to say, I want to give this price for the seat, and now, let me change it while you're actually processing, totally existed in the wild. Client-side pricing's 10 years old, thereabouts, I guess is when the CD Now case was, or CD Universe, and we still have it. It's crazy.
So all secrets must be stored on the server. There's just no way, and obfuscation here is not going to help you. We'd like you to obfuscate your JavaScript. It's a good idea, but it is not a defense in and of itself. Relying on that on itself would be security through obscurity, which we all know is a terrible idea. So include it as part of your defense strategy, part of a larger one.
We got to show this because this is fun. This is something we kind of built in-house at SPI, and we're pretty surprised because we got tired of trying to analyze obfuscated JavaScript code. It was very annoying. So you can't obfuscate it, right? The computer's got to understand it. The interpreter has to understand it. So we just went ahead and did JavaScript static analysis. So we've got... Let me go ahead and pull this up. Open with Notepad. So this is Google Suggest in all its magnificent glory. Have fun figuring out what a.value.ax parenthesis does. So we're going to go ahead and, where'd the mouse go? Oh, there it is. All right, so the very first thing is we got to get some fun white space in here. So obviously the first thing we do is try to make this thing a little easier to read. We've got a readout over here of all the JavaScript tokens. So we actually have tokenized the language. So you can name your variables whatever you want. You can't mask the fact that they're variables. We pull up all the variable names and functions that you're actually using. We got a list of the string literals that you're using. We see some things here that look like hex triplets. So they're probably doing, some cascading style sheet manipulation, some background images, autocomplete, Microsoft XML HTTP. So they're obviously invoking AJAX, different things like that. And actually, we've got a sexier version that, unfortunately, I can't show you right now, where actually we can start right-clicking on variables and actually do full-blown stack analysis. Show me everywhere this variable's used. Show me if they rename it. Show me how it passes between functions. Show me how often, or which functions are called more often than others. Show me any type of operation that's applied to this variable so I can check to see what type of validation you're doing on the client. Things like that.
So again, obfuscation is great, but there are tools like this that will undo it.
Right.
Stop some of the script kiddies, and that's a good thing. Do it, but don't rely.
Yeah, I mean, seriously, we went from idea to that in about 2 days, so it's not really all that difficult.
What does script do in the hyperfication?
So that is one that we pulled actually direct from the site that was hosting the sign up for the conference. And the scary thing was, it wasn't like we contracted them and they built us this site. This was one of those register your conference with us and we'll take care of the checkout process. They had thousands of conferences referenced or registered with them. Every single one of them were client-side pricing. So we started looking for, shall we say, scandalous types of conferences that we might want to attend free of charge, and found a couple actually here in Vegas. So
again, the control flow manipulation we talked about, just like we store all the secrets on the server, you have to enforce prerequisite call logic on the server. If you've got a 4-step process, so hold the flight, or hold the seat, book the seat, debit the account, release the seat, if all these 4 things have to always happen in a certain order, then they must be done on the server. You can't expose each of them as a separate operation to the client. Now, what you're going to say to this is, well, then you can't really have AJAX, can you? Because it's a long operation. Well, you can. If the reason you're doing it is to provide small status updates, then just have one monolithic function and then provide a second method that can get called asynchronously to pull for status. This is your secure way to do that.
Exactly. Remember, you can't trust the client, and thus you can't expect the client to run the JavaScript in the way that you give it.
So the exposed administrative functionality we saw, it's important not just to lock down the page, but lock down each method. This is what we were talking about as part of the attack surface. It's not enough just to say, oh, you can't get to this page. You've got to check authorization and authentication on every method as well. And separate your script libraries according to their function. Avoid those monolithic libraries where possible. And finally, in the injection attacks, fix the injection attacks first. The underlying vulnerability here was not the client-side data transformation.
That's not a vuln.
It was the SQL injection. The client-side data transformation just made that much worse. So the first things first is fix your SQL injection. Whitelist validate your input, use parameterized queries. You've all heard us say this 1,000 times before. But what you haven't heard us say is whitelist validate the output as well. If you know that the format going out should be one field of a string, another field with an int, and another field with another string, then enforce that on the way back out. Don't just say, okay, whatever the result is, I'm just gonna send it back to the client without looking at it.
This is especially true if you're using data sets in ASP.NET, because it can put multiple tables into it. And so a lot of times it has to do with how the tables are alphabetized. And so you want to make sure that not only that one table got returned, but that one table is actually the table you were looking for in terms of columns and everything else.
So I know this is going to be an extremely unpopular suggestion, but as a last resort, you want to consider abstinence from AJAX. Only use AJAX when it's really necessary. Just because you can is really not a good reason.
Just because all your friends are doing it doesn't mean that you're ready for it.
Exactly. So if you've got applications that are asynchronous in name only, like you're making AJAX calls, but there's nothing for the user to do but sit there and wait for it to come back, that's probably not a good candidate for AJAX. Or if you're updating, 80 or 90% of your page with a partial refresh, probably not a good candidate for AJAX.
All right. So we actually are giving away these fun-filled T-shirts, and the puddle glows in the dark. I didn't, seriously, we didn't design these. Marketing came back to us and we're like, wow, we thought we took that to a level and you just blew right past it.
We were told we went right up to the edge of good taste and then crashed through that line.
So all you need to do, we've got a bunch of these Ajax, or these Spy Dynamics stickers and these little Stop PA. We want you to take these and, in a non-destructive manner, take a photograph of it in a, shall we say, a creative place. We leave it up to you to define what creative is. Either come by the Spy Dynamics booth out there or send an email with the picture to nopa@spydynamics.com. And oh, by the way, using this as the censor bar for the goatse image is not considered creative. We've already gotten some of those.
So everybody who turns one in gets a shirt, and then the one that's judged to be the most creative and best gets a video iPod in the last hour of the show. So that's pretty cool. Now, we would also be totally remiss if we didn't at least pimp our book a little bit. So we do have an Ajax security book coming out. The first half of this book is available as a rough cut on Safari right now, so please go up and buy it. And you can get a sample chapter of it by stopping by our booth and learn all about more premature Ajaxulation.
Our book is right, or our booth is right out there. Actually, the person who had the stickers seemed to left, so unfortunately,
I think they're handing out stickers.
Oh, they're handing them out at the door. Fantastic.
So, are there any questions?
Everyone set? All right, great. Thank you.